As I mentioned before, those prevailing winds we saw for January and July, those prevailing winds actually then make ocean currents. So here we have an assortment of ocean currents. The blue ones are actually cold ocean currents, and the red ones are warm ocean currents. Not surprisingly, the cold ones are going towards the equator, and the warm ones are going away from the equator. So those ocean currents actually work together to create something called ocean gyres. So an ocean gyre then would be a combination of ocean currents that then create this whole kind of circle within an ocean basin. So, of course, we have, here we have, and I used to get my Atlantic and Pacific mixed up, but here we have the Atlantic Ocean, and here we have the Pacific Ocean. But notice that we have a South Atlantic Ocean gyre and a South Pacific Ocean gyre. So that's four, and the fifth one would be this Indian Ocean gyre right here. So there are five kind of major ocean gyres. And one of the things that is so awesome about our planet is these actually warm currents going towards the pole and these cold currents going away from the pole actually help to kind of smooth out the energy imbalance that our Earth has. I think that's neat. So I'm leading up to the last topic, and actually has to do with oceans in this part, last topic in this part. So one of the cool things, there's so many neat things, is this phenomenon called upwelling. Now, in order to understand upwelling, I'm going to kind of focus here between Peru. Here's actually South America, and Peru's over there. And here we have Australia and Indonesia. And they are actually in the Hadley cell. So as they're in the Hadley cell, we have the easterly trade winds marked right there. Now, under normal conditions, these actually trade winds, of course, create these ocean currents, okay? And these ocean currents then actually create a phenomenon along the coast of here, South America, called upwelling. And I don't know if you can see it very well, but what upwelling is, and the name kind of gives it away a little bit, this is actually kind of under the ocean here. The upwelling brings cool water up, and actually it's not just cool, it's also nutrient rich. So upwelling is like a very good thing for for little marine life, and then also for the fishermen that count on that marine life. Okay, so upwelling is a good thing, and it occurs on the western coasts of continents such as California, or in the state of California, here along South America, and West Africa. So now, like I said, normal conditions. Now we're going to segue between the opposite, or in contrast to normal, are these El Nino and La Nina conditions of basically the global wind patterns. Okay, so let's see, is that what we have next? Okay, I'm going to start with El Nino. So in an El Nino event, what happens is that our easterly trade winds, they actually can peter, or they slow and or even peter out. So this is throwing me off a little bit. Sometimes I've seen these El Ninos actually, see, this is where our easterly trade, I've even seen El Nino just kind of go like this, where now we actually have a prevailing westerly wind. What happens then is, I'm going to go ahead and put an X here, we don't have that upwelling. Okay, so we have kind of, like this slide says, or what this figure says, it's warmer than normal, okay? Now, how long do warmer, and it's nutrient poor. So fishermen and little or marine organisms do not like El Nino events along these west coasts. They can last, El Nino's condition can last 3 to 7 years, okay? So, like I said, the fishing economy suffers. So the thing is then, is we kind of have some weather patterns stalling out. So these guys over here, kind of like the figures show, gets extra rain, extra precip, okay? And these guys over here are cooler and they are drier. Now when I say over here, I'm talking about Australia and Indonesia. Okay, so I could put sad face there. And actually, we can, how do we know you're in an El Nino? Well, that looks like a crazy face. You know you're in El Nino if this is warmer over here, and actually if sea levels kind of start to drop over here. Okay, now I'm saying that El Nino affects just this part of the world. Now, this is called, actually, I believe it's called the Walker, W-A-L-K-E-R, Walker circulation, kind of this sort of circulation right here. And that actually doesn't, it has consequences throughout globally, okay? I don't have a slide to show you necessarily, but just trust me, it has consequences globally. The Farmer's Almanac, one of the things they look at is, are we in an El Nino condition or a La Nina condition? And we look at the Walker cell to know, but it affects everybody. And I can never remember, so I wrote it down. So tropical cyclones, otherwise known as hurricanes in our neck of the woods, actually are diminished when the weather pattern for the Walker cell is El Nino. So we have normal El Nino, and then we have La Nina. And La Nina actually is where your easterly trade winds actually are intensified. So you might be thinking, well, if they're intensified, extra strong, then we have an extra strong upwelling, and we do. That makes everybody happy? I don't know. A little bit cooler than usual, and then actually a little bit, I believe, drier than normal. These guys are drier, and these guys are wetter, okay, during a La Nina. So more precipitation then as carried along with those intensified easterly trades over to Australia and Indonesia, according to the Walker cell. Okay. Then with regard to cyclone activity, tropical cyclone or hurricanes, we can expect actually an increase in seeing worldwide tropical cyclones. So now I've gone ahead and I have a link here. I'm not going to necessarily click on it, but this Southern Oscillation stands for, well, maybe I will click on it. What the heck? Southern Oscillation refers to kind of the going back and forth between normal, El Nino, La Nina, okay? So I just checked it a little bit ago, and we are actually in a La Nina event right now. So it just simply means that the easterly trade winds are intensified. Remember, one of the things is we can expect more chance for hurricanes. Okay. So, like I said, how do you know what event we're in? Well, one of the things is to look at the sea surface temperatures. Remember, during an El Nino, it's going to be warmer there off Peru, and during a La Nina, it's going to be cooler. You look for where the precipitation is. This actually, the red, blue, the blue is the La Nina, and the red is the El Nino. And then the last thing I have here is the sea surface temperatures. So the black, hopefully you can kind of see the silhouette of the South America there. Okay, so here we go, South America. And the reds then would be actually warm sea surface temperatures. It means that you don't have the upwelling like usual, and so that's associated with El Nino. Here, these kind of cooler than usual temperatures mean that you actually have intensified easterly trades, and you have a La Nina event.